In this lecture, I mentioned that economists usually pick a specific math function to define a utility function. What should that function look like? Well, it depends on the situation. The specific function you use can look really different depending on the person and the type of goods we're talking about. In this exercise, let's play around with what different utility functions could and should look like. Let's use cookies and slices of pizza and try to come up with a function that shows how happy you are with different amounts of each good. What if your utility function looked like this? U equals P minus C. Let's say you start with 4 slices of pizza and 1 cookie. What's your utility? U equals 4 minus 1 equals 3. Now what happens if you add 1 cookie? Utility becomes U equals 4 minus 2 equals 2. Utility dropped by 1 when you got 1 more cookie. That doesn't make much sense. In general, we assume the stuff you consume makes you better off, not worse. So it's weird to have a utility drop when you add a good. The negative sign doesn't make sense, so let's try something else. How about U equals P plus C? This works better. Now if we have 1 of each good, we get utility of 2. If we add another slice of pizza or another cookie, utility goes up. That feels more realistic. But we have a different problem now. Let's say you start with 1 cookie and 1 slice of pizza. So U equals 1 plus 1 equals 2. Now add 1 slice of pizza. Utility becomes U equals 2 plus 1 equals 3. So your utility goes up by 1. Now let's say you start with 10 slices of pizza and 1 cookie. Your utility is 10 plus 1 equals 11. Now you're totally full. You can't imagine ever being hungry again. But let's say you add 1 more slice of pizza. Utility goes up to 12. It went up by 1. But this is weird, because the second slice of pizza also made your utility go up by 1. This violates our assumption of diminishing margin utility. It'd be pretty weird if the 10th slice of pizza made you just as happy as the second slice. The bottom line is this. We can use lots of different utility functions, but the purpose of utility functions is to reflect what your actual preferences are. So we want our utility functions to be realistic and be easy to work with. Realistic means more of a good makes you happier, or at least no worse off. And realistic also means you have diminishing margin utility. So the millionth slice of pizza doesn't make you as happy as the first slice. U equals square root of P times C does both jobs. It's pretty realistic and it's pretty simple. Let's say you start with 1 slice of pizza and 1 cookie. That gives you utility of U equals square root of 1 times 1 equals 1. If you add 1 slice of pizza, utility goes up to square root of 1 times 2, which equals 1.41. So you're happier. Utility goes from 1 to 1.41. Now let's say you start with 10 slices of pizza and 1 cookie. Your utility is square root of 10 times 1 equals 3.16. But now you're totally full. You've had more pizza than is normal for any human being. Now let's say you add 1 slice of pizza. Utility is now square root of 11 times 1, or 3.31. It still went up. More pizza can't hurt. But it went up by less than before, when you went from 1 to 2 slices. That's exactly what we think makes sense. So in general, there are different types of utility functions we can use, but the square root function's a nice one. In fact, the square root button's right in your calculator, and it behaves kind of how we think real people act.